Hey, class. So what we want to do here is look at E and Z. And so this is the way we can look at a double bond instead of using cis and trans. Right? So when we do E and Z, it's just a more effective way of kind of designating a double bond is either trans or cis. Right? And the problem is if the groups aren't the same, then sometimes it's hard to know what you're talking about. Like if we're talking that cis means the same side and trans means opposite, if the groups are all different, then what are we referring to as being the same side or opposite? So this is a kind of a way like RNS as well that gets around those problems. All right, so the first thing we want to talk about is how do we rank these, right? So if you remember when we talked about RNS of a chiral center, is we're going to use the priority rules based on the atomic number of the atom. And if they're the same, then we're just going to systematically move our way out, right? So we look at the first atom. If they're the same, then we look for the next biggest atom attached to it and compare those two. And then we just systematically work our way out. Right? Now, if they're the same atom, like you hit two bromines and you're like, well, there's nothing else, then actually that means that there wasn't really a stereo center, right? In terms of being able to designate it as E or Z. And we'll look at those here in a minute. All right, so what we want to look at is the two molecules down below. And so when we're comparing groups, let me highlight the way we're going to look at this, is we're going to look at a carbon, and we're going to look at the two groups coming off of that carbon. So essentially, we're only comparing the stuff in blue, and then we'll do a second comparison of the stuff in green. Okay? And the way this is going to work is we're going to draw a line right through the double bond. So we'll take our double bond and we'll draw a line. We'll do the same thing here, take our line, draw a double. And what you want to see is after we've ranked the two groups coming off the carbon as either higher or lower priority, then we'll do the same thing with the other carbon. We'll rank the two groups and we're only comparing those two and we're only comparing these two. If the two higher groups end up being on the same side, it's going to be Z. Excuse me. Sorry about that. If the same two groups are higher, right, on the same side of the double bond, it's Z. If the two higher groups are on opposite sides of each other, they're going to be E. Right? And the way I remember that is E for either side of the double, right? The higher groups on either side of the double. All right, so let's give it a try. I think when we look at it, it probably makes a little more sense. So what we want to do, and let's do the first one together, is we're going to try to name these. All right, so we'll review a little bit of our alkene naming, but then we're going to designate that double bond as E or Z. All right, so if you remember when we name something, we want to start numbering from the side that gets through the double bond the fastest. Right, so on this one, we'd start on the left, so it'd be 1, 2, 3, 4, 5. All right, so we have our 5 carbons, so that's going to be pentene. And then we have to say where the double bond is. So it's on carbon 2 and 3. So we pick the lower of the two numbers, so it's 2-pentene. And then any of the groups we haven't named yet. So there's a carbon up on carbon 3 and a carbon on carbon 4. So it's going to be 3,4 dimethyl, right? We use the prefix di because there's two of them. So dimethyl 2-pentene. Now, the only thing we're missing is that designation if it's E or Z. Right, so let's give this a try. So one thing I'm going to do, if you don't mind, is let me erase the numbering just to make it a little less cluttered. And there's also a hydrogen implied here. So let's draw that in. So the first thing we want to do is we're going to compare the hydrogen to the carbon. Right, so we're only comparing those two. We look at our periodic table and we see that carbon is bigger than hydrogen. So this gets to be our higher priority. Right. Now we'll come over here and let's change the colors. So I'm going to use a purple and we're going to compare this carbon to this one. All right, they're both carbons, so they're tied. So now we look for the next bigger group. This one's a hydrogen that's implied. This would be one of the carbons that's coming off. So this group gets to be higher. Now we draw a line right through the double bond. And if the two higher groups are on the same side, then it's Z. So we just put the Z in front. All right, so if they're on the same side, it's Z. If they're on either side of the double bond, it's E. All right, so why don't you go ahead and try the rest of them. So pause the video, give them a try, and then we'll do them together. All right, so hopefully this went well for you. Let's just go ahead and we'll actually name them and then do E and Z all together so we can get good at everything. So we'll start here on the left, and we have to number through the double bond. So again, it's 5 carbons, and it's on carbon 2. Right? So the double bond is between carbons 2 and 3. So again, will be 2-pentene. Remember, the ene is telling me the double bond. And actually, the only substituent we have is that chlorine, and it's on carbon 2. So it'll be 2-chloro, 2-pentene. All right, so naming wasn't too bad, right? Anytime we have a halogen, we drop the ene at the end. So instead of chlorine, and put O, so it becomes chloro. Or instead of bromine, it becomes bromo. And then we always give the number that it's on. All right, now, the same as before, I'll erase our numbers just to kind of make things a little less cluttered. And so we're going to compare the chlorine and the carbon, and I'll put a little dot here where I'm going to draw my hydrogen, right, and the hydrogen that's implied. All right, so if we compare chlorine versus carbon, remember we use the atomic number. Chlorine is bigger than a carbon, so this one gets to be higher. So it's the higher priority. Carbon is bigger than hydrogen. So since the carbon's bigger, it gets to be the higher priority. We draw a line through the double bond. And now in this case, the 2 higher priorities are on either side of the double bond. Right? So if they're on either side of the double bond, we'll put an E. All right, so this is an E designation. So not too bad, right? We're kind of getting the hang of it. All right, let's try another one. So we'll start here on the far left, and we'll number through. So 5 carbons, again, it's pentene, and it's actually 2-pentene again. Now, all the substituents that we weren't in that red numbering, so this group took care of these carbons. So we have the 2 methyls and a chlorine. And so it'll be dimethyl and 1 chloro. Remember, we're going to compare the C from chlorine versus the M for methyl. We don't use the D for the prefix, even though it still would have put the chlorine in front. So it becomes 1 chloro. Let me actually move this over a little bit to give myself a little more space, and then I can fix it once we're there. And so now it's off carbon 2 and carbon 3. So it'll be 2,3. We use the prefix di to say there's 2 of them, since it's the exact same group. So it's 2,3 dimethyl dash, and then 2-pentene. Okay. And so we draw this. So we get it right there. So 1 chloro, 2,3 dimethyl, 2-pentene. Now the last thing we want to do is solve for the E or Z. So let's color code them again like we did before. So we're going to compare this carbon versus this one. And we'll compare this carbon versus this one. All right, so if we're looking at the 2 orange ones, they're both carbons, so they're tied. So now we look for the next biggest thing attached to them. On top, the biggest thing it's attached to is a chlorine. Biggest thing it's attached to here is a hydrogen. So the top one gets to be the higher priority. So write higher. Over here, it's attached to a hydrogen. Here it's attached to a carbon, right? Because the 2 carbons were tied. So we look for the biggest thing attached to them. So this gets to be my higher priority. We draw a line right through. They're on either side of the double bond, right? Remember, if they're on opposite sides of the double bond, then it becomes E. Right? So we put our E in front. And so it's E, 1 chloro, 2,3 dimethyl, 2-pentene. Right, so I think we're starting to get the hang of it. All right, let's try one last one. We'll number here on the left, 1, 2, 3. And remember, even though there's those chlorines and bromines, we only number carbons, right? And that was the same for letter C. We only number carbons. We don't number any other groups. Right? So we're always, our parent chain is just the number of carbons. So 3 carbons is pentene, or sorry, propene. And this time it's on carbon 1. So it's 1 propene. Move it up here just to give us a little more space. And then we alphabetize the other group. So off carbon 1, there's a bromine. And then also off carbon 1, there's a chloro. So it's 1 bromo, 1 chloro, 1 propene. So off carbon 1, kind of everything comes off of it. Okay. Now we're going to do the same thing we did before. We're going to compare the 2 in green, and we'll compare the 2 groups in orange. And don't forget there's a hydrogen implied, so that's what we'll actually compare in orange. So we just go to the periodic table. We see which of these 2 has a bigger atomic number. It's bromine. So this time I'm just going to be lazy and put a star by the higher group. Same thing over here. Compare the hydrogen and carbon. Carbon's bigger. We'll draw a line. And since the 2 higher groups are on the same side, it gets to be Z. Put the Z in front. Put it here just for emphasis. And so this is how we decide if a double bond is E or Z designation. Right? So cis and trans, kind of that same idea. Cis means same side. Trans means opposite. The other designation we can use is E and Z. So E means that the biggest group is on either side of the double bond. Z means they're on the same side of the double bond. So it doesn't matter top, bottom, left, right, just that they're on the same side of that double bond. All right, class. I hope that was helpful.